we're diving into something that's honestly both fascinating and incredibly urgent. We're looking at how the rapid digital transformation of our factories has inadvertently opened the door to massive, high-stakes cybersecurity vulnerabilities. Basically, we're talking about the exact moment the physical world collides with the digital one. Look at this number. Over $1 million. To put that into perspective, that is the potential cost of just a single hour. Yes, 1 hour of production downtime when a modern manufacturing facility gets compromised. In this industry, time literally is money, and you better believe cybercriminals know exactly how to leverage that against manufacturers.
All right, let's get right into Section 1, the Industry 4.0 paradox.
So, Industry 4.0 has obviously brought some incredible innovations to the factory floor, right? Stuff like AI and robotics. But by connecting all of this to the internet, we've rapidly expanded the cyber attack surface. To really grasp the risk here, you have to compare traditional IT networks with OT, or operational technology. IT manages your standard business servers and cloud data, sure, but OT? OT directly controls the physical machinery, the robotics, the sensors, the actual physical production equipment on the floor.
And I think this quote brilliantly illustrates the core problem we're facing. Historically, OT systems were completely isolated, but now they're blended with IT for efficiency. So what does this all mean? It means a digital flaw that used to just affect a corporate office network now carries dangerous, tangible, physical consequences on the factory floor. Moving right along to Section 2, why hackers target manufacturing.
You might be wondering, why has manufacturing suddenly become one of the absolute most targeted industries for cyber attacks? Well, hackers are exploiting the simple fact that manufacturers absolutely cannot tolerate downtime. It is for sure their Achilles heel. Add to that the blending of those IT and OT networks we just talked about, a treasure trove of highly valuable proprietary processes, and an extensive reliance on third-party vendors, and bam, you have the perfect storm for extortion.
Furthermore, we really have to consider the hardware itself. A lot of factories run on legacy equipment built decades ago. We're talking machinery that's been operating for 20 to 30 years, often running on completely unsupported operating systems with vendor default passwords. And replacing this heavy industrial gear? It's incredibly expensive, making it a glaring, yet super difficult to fix weak spot. Let's look at Section 3, the common cyber threats.
These vulnerabilities essentially pave the way for specific modern cyber threats that are actively hunting interconnected industrial environments right now. First up is ransomware. Now, this is particularly devastating in manufacturing because encrypting production data doesn't just lock a computer screen, it brings actual physical operations to a grinding halt. This puts immense pressure on the organization to quickly pay the ransom just to get the production lines moving again.
Then we have software vulnerabilities. Flaws in manufacturing execution systems or industrial control software allow attackers to execute malicious code remotely. And get this, without proper network segmentation between the office and the factory floor, attackers can easily move laterally. They just cross that IT to OT bridge straight into the production environment. And we definitely can't ignore the supply chain. Manufacturers rely so heavily on external software and contractors. So, a vulnerability introduced by just one single trusted supplier can compromise the entire facility. This is exactly why software bills of materials, or SBOMs, are becoming totally crucial for identifying those hidden weak links inside third-party software components.
Section 4, real-world costs and cascading effects.
Okay, so when these threats actually successfully breach a facility, the fallout goes way beyond a typical corporate data breach. This is perhaps the most alarming consequence: physical hazards. Attacks on OT systems can literally disable safety mechanisms and alter alarm thresholds. That means a cyber attack directly threatens worker safety on the floor. And in the absolute worst-case scenarios, it could cause major industrial or environmental disasters.
Beyond those scary physical hazards, the operational and economic fallout is staggering. Operationally, you face extended downtime. Economically, you're looking at massive incident response costs, combined with missed deadlines and painful contractual penalties. And reputationally, you risk a huge loss of customer trust, not to mention the potential theft of your proprietary trade secrets.
And the damage rarely stops at the factory gates. Because modern manufacturing relies on these huge interconnected ecosystems, a single exploit can trigger a devastating domino effect. Think about it. An attack on an energy provider halts electricity, which stops factory production, which in turn causes massive disruptions all the way down the line for raw material suppliers and global logistics. It's wild. On to Section 5,
Proactive vulnerability management.
To combat these massive physical and financial stakes, the industry has got to make a fundamental shift. We have to move from just reacting to incidents after the fact to utilizing proactive vulnerability management. And it's really vital to note here, this isn't just a one-time assessment. It's a continuous, ongoing life cycle designed to identify and reduce cyber risk while, and this is the absolute key, keeping the production lines running safely.
A structured approach requires 4 dynamic steps. First, gaining complete visibility by safely discovering all your IT and OT assets. Second, prioritizing those vulnerabilities based on their actual physical and business impact. Third, applying remediations to reduce the risk. And finally, continuously monitoring those systems to build up your overall operational resilience.
But here's the thought. How do you remediate when you can't just, reboot a factory line? Since immediate patching isn't always possible in a manufacturing setting, organizations lean heavily on what we call compensating controls. This means relying on strict network segmentation, access controls, and application allow listing to isolate risks until a planned maintenance window finally opens up.
Let's look at Section 6, Overcoming Unique Industry Challenges.
Applying these security measures on a factory floor presents some really unique hurdles that are completely foreign to traditional corporate IT environments. It requires a massive balancing act. Security teams have to meticulously weigh necessary system updates against the absolute demand for 24/7 production uptime. They have to protect unpatchable legacy gear using those compensating controls we mentioned. And above all else, they have to ensure that a security update doesn't accidentally compromise physical worker safety. We see this delicate balance playing out across all kinds of sectors. Automotive plants are streamlining visibility to reduce downtime. Food processing facilities have been hit hard by ransomware that forced completely halted operations. And, incredibly, in high-tech manufacturing, we've even seen cases where routine, poorly planned security scans actually accidentally crashed highly sensitive production machinery. No way, right? But it happens.
Navigating all of this really comes down to one ultimate goal. It's a tightrope walk where the objective isn't just achieving a perfect security score, it's about reducing cyber risk while maintaining safe and uninterrupted production. We have to secure our digital innovations to protect the physical reality, business continuity, and human safety on the factory floor.
Which leaves us with this critical thought: as our industrial base races toward a hyper-connected, artificially intelligent digital future, are our security measures truly keeping pace with the physical stakes?